We're gonna talk about a bunch of stuff on with algebra, algebra one, two, three. I mean two, geometry, trig, calculus, and pre-calculus. So specifically, some of the questions that we had from last time um, are related to do we join your YouTube live? Yes, you got to join in on YouTube. Some of the questions that we had last time were related um, to um, sequences and series. I had a bunch of questions about that, and I wanna and I wanna and I wanna make sure I address them today because some of those I've got repeated questions about series and sequences. Hey, Caden, is it Caden? Caden Love. Hey, what's going on? Yeah, so I think this is live on Facebook. Let me connect my mic so y'all can hear me better. Uh, 1 second. I'm trying to connect this mic. Hopefully, if you having trouble with the sound too, let me know. This should be pretty easy to connect. It should be connected automatically. But if you have trouble with the sound, let me know on Facebook and YouTube. And hopefully the chat works today. Yes. Okay. Domain and range, algebra. Okay. Grace, Mary. Okay. Cool. Uh, Yeah, we'll do some of that. I think we did some of that last time. We'll do some of that. Yes, you got to join on YouTube. Over and please and thank you. Yes, we'll do some stuff about domain and range. Yes. Let me double check that this is live on YouTube. It should be. I just want to make sure that you guys have it. Uh, so I'm gonna double check that this is live on YouTube. Yes, it is live on YouTube. So okay, all right. So let me and I see you guys watching too. I probably will see if I can mute those. Nope, not yet. Can you hear me? Can you hear me clearly on Facebook and YouTube? I just want to make sure that you guys can hear me. I'm gonna close those screens so I don't have a lot of stuff popping up. Okay, yeah, someone see me on YouTube. That's what's up. That's nice. Hey, pretty me, what's up? All right, cool. So, let me go to my papers for today, and we'll talk about something. If, are you guys still? Do you guys still want to see the sequences and series? Because I know it was a lot of questions about that, and I said I would address it today. Uh, do you guys want to see the series and sequences? Uh, I don't know what this yes was for. I don't know if this is what y'all want to see. Um, so we'll talk about it since I said I was going to talk about it. We'll talk about series and sequences. So today we're going to talk series and sequences. We're also going to talk about domain and range. We're also going to go into um, what else did you guys say you want to see? System of equations. So system of equations is probably like algebra one. We can talk about that. Um, and let me find a paper that I was using last time. We'll talk about system of equation probably first. I'm trying to find my paper so I can share my screen with you guys. Give me 1 second. What else you want to see? Trig identity, please. Okay. That's a long uh that's you might have to give me a little bit of reference and what exactly you want to see because this can take this can be as easy as saying that cosine squared of x plus sine squared of x is 1. It could go all the way to we could do a lot of other stuff in it. So a little bit more specific would help. Um, but we can go over some of the simple ones and see if you have other questions, additional questions, just let me know. I'm not in the paper that I need to be. What else you want to see? Geometry, angles. Okay. Okay. Someone want to see geometry and angles. What else? What else you guys want to see? Okay, I'm just gonna go and use this. All right, cool. So, I think you guys should be able to hear me. Yep. Yes. I arithmetic or geometric. I think they ask questions about both. I'm gonna look at both of them. Why do you give out free help? Uh, there's no reason specifically. I think it's probably something that's needed right now, and there is a lot of kids right now who kind of would use this. But I also do this privately too. So, and the other reason why I would say is, I was in a position where I had somebody who helped me, and I don't think I ever paid him anything. I'll be honest with you. And it's kind of nice to be able to have the opportunity to do it for other kids too. Uh, rational numbers. Okay. So, let's start. Let's start with some. I wanted to do this. So let's start with some series and sequences. So let's say the easiest way for me to think about this is, let me start with series and sequences, and then this is probably you'll see this in maybe algebra two and pre-calculus for sure. So algebra two and pre-calculus, you'll find stuff like that, series and sequences, and then you'll find it in calculus, but where it's a little bit more advanced, where they're talking about Taylor series, convergent series, and series that doesn't convert. But I don't think that's what you guys were relating to. Is just understanding series and sequences. So we're gonna go over those now. I'm gonna share my screen a little bit. Let me try to find a calculator, because some of those we're gonna need calculator for them. 3 times 5. All right, cool. So this is my calculator, and then let me share my screen with you guys now. Okay, let me know if you are able to see the screen. My computer screen. Let me know if you are able to see it, and then we're gonna go. I'll go do. Where do you? I do online tutoring, Grace. I do online tutoring. If you go to, I'm gonna type the site, uh, my website, thejxtutor.com. Yeah, thejxtutor.com. This is my website. So if you go to this, you should be able to see all the stuff that I do. And you can actually book a free call and we can talk. So, okay, yeah. So you guys say you can see the screen. All right. So the first thing that I would say in series. So let's start with things that we know. Maybe we have a set of numbers. Let's say 1, 5, 3, 8, 9, 17. Technically, this is a sequence of numbers. So it's a bunch of numbers. They don't have any orders. There's no operation. Technically, this is a sequence of numbers. And now what people start to say is like, okay, we can put some order in with these numbers. So the first thing that they started to introduce, the folks who are really, really good at math, they started to introduce what we're calling the arithmetic sequence. So a sequence of numbers, it's a bunch of sets of numbers. It can be, the first one can be bigger than the other one. This one could be negative. This one could be -2. So this is sequence. But now when you talk about arithmetic sequence, so you start to say, okay, it's a sequence, but also it's arithmetic. So there's an order to it. There's a way for you to find, the terms that you want. So when we're talking about arithmetic sequence, and the easiest one that we know is the one that we use every day: 1, 2, 3, 4, 5, 6, that. Now, how do we find now, let's say if I wanted to tell you, how do we find if I'm at 2 and I want to get to 3, what do I need to do from 2 to get from 2 to 3? What do I need to do to get from 2 to 3? And then that's the rule for that specific sequence. So remember, when we started, I started out saying sequence is just a bunch of numbers. But when we talk about arithmetic sequence, it's a sequence, but it's also follow a certain rule. Now we're gonna try to see what that rule is by giving you guys an example. Add. Okay, Leslie, say add. What do you add? Leslie, what do you add? So let's just say we add, and what do you add from 1, 2, 3, 4? Let me go and see the comments. Yeah, +1, purified 0, +1. Yes. So yeah. Hey, Miu. So yeah, you add 1. So that makes it an arithmetic sequence because there's a certain order. So now there's a certain rule to follow. So what they say is, if I want the next, if I want the next term in this sequence, so all I have to do is add 1 to that 2. 2 plus 2 is equal to 3. That's how you find the next term in the sequence. This term, if I want to find the other one, I add 1. So every time I need to find a term, I just add 1 to the previous one. So I just add 1 to the previous one and add 1 to the previous one. Now, because this patterns, it follows this pattern. So what people would try to do is say, okay, let me try to come up with a formula to say, if I know this term, how do I find a term that's in the 10th term, the 15th term? If I know the first term, how do I find the 15th term, the 17th term? Now let's start with basic example that we have. Let's say that we know this is the series that we're talking about, the sequence that we're talking about, 1, 2, 3, 4, 5, all the way out to 2, 3, 4. And I'm not gonna get into notations and all that stuff. This is probably more for if you're reading the textbooks, you'll probably see more of them. But I just want to explain it to you guys so you can understand it in this case. And 7, 8. Now, all the way out to infinity. Now, let's say if I know the first term is 1, and I want to find the 5th term. So let's say this is A1. So, and we use indexes to do this. This is A2, A3. We'll call this A4, A5. And then if I want to know A6, now, because I have it in front of you, if I know A1 as 1, to find A5, all I have to do is add 4 to it. To find A17, all I have to do is take the A1. This is not that much interesting. It's actually confusing, this one, because the first term and the term that you're adding is the same. So to find A17, all I have to do is add 16 to it. Now, let me look what we're doing here. So to find A2, let me use a different color so you understand what I'm doing. To find A2, I take the first term, which is 1, the A1, and I add 1 to it. That's A2. To get to A3, I take the first term, A1. To get to A3, I take A1, which is 1. I add 1 to it, that gets me to A2. I add another 1 to it, that gets me to A3, right? To find the 4th term, I take A1, I add 1 to it, that gets me to A2. I add another 1 to it, that gets me to A3. I add another 1 to it, that gets me to A4. Now, let's say we need A5. And then this is going to get tedious after a while. So what we're going to do is A5, I add 1 to it, I add another 1 to it, that gets me to A2, A3, A4, A5. Now, how do we come up with a formula from all that stuff that we're seeing? How do we come up with a formula to find the A, let's say if I want A 2001? How do we come up with a formula to find that without have to repeatedly adding 1, 1, 1, 1? Now, let's start with some definitions. So the 1 here is what, the common difference. So the 1 is the term that you add to each to the first term to find the next term or the 15th term. So in this case, when I needed A2, I added one time. I added one time. So A2, so I take the A1 plus, I add one time. When I needed A3, I take the A1, and I'm going to use a different color so you don't get confused in this. When I needed A3, I took A1, which is the first term. I added 1 2 times, right? When I needed A4, to find A4, I took the first term, A1, and I added 1 3 times. Times 1, you add that 3 times. Now, if we call 1 the common difference, how many, you're welcome. You're welcome, Farah. So if we call 1 the common difference, how many times I need to add 1 to find A5? How many ones I need to add? How many of the common difference I need to add to A1 to find A5? So what I'm saying is, in other words, if I have A1 and I need A5, what do I need to do? And I know you guys smart. I'm gonna wait till you answer it. So 4. So okay, 4. Okay. So I added this 4 times. I added A1. I added the common difference, which is 1, 4 times to A1 to find A5. So A1 is the first term. And then the term that I'm looking at that I want is A5. Now, if I want A 2017, how do I find A 2017? So A 2017, how do I find that? How do I find that from A1? So I don't want to count A1 plus, I don't want to count 1 plus 2 plus another 1, 3 plus another 1, 4. I don't want to count that. If I need A 2017, how do I find that from knowing A1, the first term, from knowing the first term and also knowing the common differences, which is 1, the common difference they call D is 1, knowing that. So how do I find A 2017? I know you guys, yes, 1 plus 2016, purified 0. That's what's up. 1 plus 2016. So what we did is, so it's 1, which is A1, yes, A1 plus that common difference 2000 plus that common difference 2016 times. So you add it to itself 2016, 1 plus 1 plus 1, 2016 times. So now we can probably come up with a formula for it. It may not look as obvious in this case, but what we're gonna do is give you another example where it seems a little bit obvious. So if I need AN, so I can take A1 plus, how many of the common difference do I need to add? So how many of them I need to add to A1 to get to 2006 to get to AN? So if I need AN, and this when I started with you guys, before you answer, I mean, if you answer, that's great. But I'm going to explain the question to you. So when I started, if I needed A2, all I had to do is take the first term, which is A1, I add the common difference, which is 1 to it. To find A3, I take the first term, I added the common difference twice, which is 1 times 2 times. So if I need the A4, I take the first term plus, I added the common difference 3 times the common difference. And you guys told me if I need a 2017, I just need to take the first term and I add the common difference. I add it to itself 2016 times. So if I need AN and I know the first term, what do I need to add to it to get AN? And let me see the answers. Purified 0. You guys understand the question? Yes, no, maybe? So what do I need to add to a 2016? I mean to A1 to get to AN. So to A1, and this might seem a little bit confusing because the common difference is one. So it would be that one n minus one times. So the where n minus one comes from is, you see right here is 2017 we needed. We added it 2016 times. Let's go up. We see right here what we needed. We needed A2. We needed A2. We added that common difference one time. We needed A3. We added it twice. We needed A4. When we needed A4, we take the first term plus we added that one three times. Now, let me yes, the common difference. So let me give you a different example, and then we're gonna go into series. So to give you a different example that helps you understand this a little bit better, because this case right here was a little bit hard for you to understand because it wasn't set up. It was kind of confusing in a way that the common difference was one, and then you added it however many times. So let's say that we have a sequence of numbers. Let's say A1, which is 5 through 8, 11, 14, and 17, 21, dot, dot, dot. Now, this goes all the way out to infinity. So let's say that we wanted to know so let's say we call this the first term, A1. So A1 is 5. A1, the first term, A1 is 5. A2 is 8. A2 is 8. A3 is, and this probably make more sense here because the numbers are different, and you will see what I'm saying better, is 11. A4, this is A4. This is A5. This is A6, and all the way out to infinity. So now let's say if I need to get to A2, what do I need to do from A1? So if I need A2, what do I need to do from A1 plus what? A1 plus what? How do I get to A2? I don't know how I got 21 instead of 20. Thank you. 8, 11, 14, 17, 20. Yeah. Thank you. So how do, yeah, plus 3. That's right. Plus 3. Yeah, plus 3, not 1. So, yes, the common difference is 3. So, plus 3. Now it's 3. Now, if I need A3, would be A1 plus a 3 plus another 3. And I'm writing it like that for a reason. If I need A4, and you can calculate this if you want. So A1 is 5 plus 3, which is 8, plus another 3, which is 11. So this gives us 11. So 5 plus 6 is 11. A3 is 11. And if we go back right here, A3 is 11. Now, if you have all of this in front of you, you could say this is A1, this is A2, this is A3, this is A4, this is A5, this is A6. Now, what if I want A214? How do I find that? What if I want A214? How do I find that? So what if I want A214? How do I find A214? And I'll get to that in a second. So now, to find A3, I take A1, and I add it to itself twice. To find A4, I took A1, I add the common difference. I added the common difference 3 times. And to find A5, and you guys already see what's coming. I took A1, which is 5. I added the common difference 3 times, 4 times, 4 times. Now, So what does that tell you? So now if I need A5, in other words, the other way to write this, A5 is A1 plus 4 multiplied by the common difference, 3, which is 3. And how do you find a common difference? You take any two terms, you subtract them from each other. You take this away from, take the biggest one, two consecutive terms, take the biggest one minus the one that precedes it. 14 minus 11, 20 minus 17, 3. 8 minus 5, 3. 11 minus 8, 3. That's the common difference. That's how you find it. You just take one minus the other one. Now, let me go scroll down a little bit. So if I need A5, all I have to do is take A1 and add 4 times 3. Now, here's how we know what formula we need to write. When we're writing these formulas in terms of, n, what you look at is the index. So the index here, 5, A1 doesn't change here, doesn't change any times. The common difference doesn't change. This number 4 here is what? Is 5 minus 1. Okay? So it's 5 minus 1. So now what this saying is, if I need A of a certain index, take the first term and then take 1 less than whatever the index is, multiply it by the common difference. You understand what I'm saying? So now if I need let's say if I need A12, all I have to do is take the first term plus 1 less the index. The index is 12 right here. 1 less the index, 12 minus 1, times the common difference, which is 3. Those two don't change. All that's changed is this. Now, how do you find, can you tell me what's A 161? Can you guys tell me what is A 161? That's the question. I'm gonna give you guys a couple minutes. I don't know if you have a calculator. So how do you find A 161? Let me see if you guys can find this. And if you're on Instagram, please go on YouTube. That's how you'll be able to see the screen. Otherwise, this won't make sense to you. So A214 is A213 times 213 times 3. That's right. That's good. Okay. Yes. Good job. Purified 0. That's what's up. Yeah, that's how you find it. You find A161 is A1 plus 160 times the common difference, which is 3. That's good. Yeah. So, and what purified 0 said is A 160 A1 actually. That's not what he said. A1 plus 160 times the common difference, 3. A1 is 5 plus 160 times 3. Now, they didn't even have to give me this. And normally they won't, because no one has time to write all of this at the same time. I don't know why my stuff is going this way. So normally they won't give you all those. No one has time to write all of these numbers all the way to the 161st term or 214th term. So they're going to give you a few of them and say, hey, how do you find the rest? Does that make sense? Am I making any sense, guys? Am I making any sense? Now, from all this, we can find AN. And remember what I was saying is, if I need A of anything, all I have to do is take the first term, and then I look at what index I have. In this case, the index was 161. I'm going to change color so I can emphasize this. The index was 161. So I take the first term, A1, and then I take 1 less than the index, and I multiply it by the common difference. How do you find the common difference? Take any two terms if it's an arithmetic sequence. Now, that's a big difference. You got to emphasize that. So how do we find the common difference? Take any two terms, 14 minus 11. So take any two terms, take take this one by the one that precedes it. So 14, take away the one that precedes it. 11, 14 minus 11 is 3. 17 minus 14 is 3. 20 minus 17 is 3. So that's how you find a common difference. Now, to find a to, a 161, all I had to do is take the first term and take one less than 161, which is 160, multiply that by the common difference, which was 3, and that's how I found it. Now, from there, can I find an? How do you find an? What's the formula for an? And I already told you guys, let's call the common difference D. The common difference in general, let's call that D. And now we're going to go in general terms, so that way, when you have any of them that you have in front of you, you can say, oh, I know this formula for this. Now, it's not about memorizing the formula, but it's understanding where it's coming from. That's why I'm trying to show you guys, because I could have said, hey, oh, it's this formula you use, but I wanted you to understand where that formula is coming from. So, let me see what you guys have as an answer. So how do you find an? An? Anyone? Answer would be 486. An, yes. There you go. A1, n minus 1 times D. That's right. Yeah, A1, n minus 1 times D. Yeah, that's how you find an. A1, take the first term, 1 less than the index. 1 less than the index, which the index is n. 1 less than the index, n minus 1, times the common difference, which is D. Now, do you guys have any questions about arithmetic sequence? And I want to see if you guys want to see the geometric sequence as well, the arithmetic series, the geometric series. I want to see if you guys are interested in seeing those. If you don't, we're going to move on to something else. Any questions about the sequence? Domain and range. Okay, we'll do a little bit of that. Any questions about the sequence? Sequence questions? Nope. Any questions? Nope. Yes, no, maybe. All right, cool. Okay, geometry. Yes. You multiply. Yeah, that's right. Purified 0. All right. Any questions? You guys want me to continue with this? Do you want to see series? Thank you, Shane. Do you want to see series? Okay. If I don't have any questions, I don't see anything for series, I will move on to domain and range, because I have a lot of people answering that. If AP Stats is a hard class, or no, it depends. That's the answer I say with those classes, with those questions. It really depends. If you've taken stats before and it's not hard for you, and you can go in and just ace it. But if you have difficulty with stats, or you had difficulty with algebra, it's probably going to be difficult. I have a calculator here. Oh man, what's my yellow calculator? So, and this is not a commercial or anything. There's a calculator. Is it TIX? Oh man, I always show this on here. I don't see it, but it's a multi-view calculator. It has, if you're taking any stats class, you can just plug in all the stuff in it, and it will give you a bunch of answers that you don't have. Stats has a lot of formulas in it. It has a lot of formulas. So normally that calculator is a simple calculator. You just plug in all the stuff in it. It will give you a bunch. You can go a whole semester without memorizing any formula, as long as you understand it too, but you also understand how to way to plug stuff. If I don't see it in my bag. I don't know where I put my calculator, to be honest with you. So if I see it next time and you ask questions again, I'll show you the calculator on the screen. I normally show it here. If you go in the video, 2 or 3 videos, maybe 4 or 5 videos ago, I show the calculator on the screen. So it depends on what class you're taking, and if you had trouble with, we had trouble with those, like algebra classes, maybe you might not be able to understand it, like geometry, because I know a lot of they use the mx plus b stuff a lot on there. Y equals mx plus b. Um, um, it's I don't want to say it's not a hard class, but it's something that you can manage, especially if you have a calculator that you can use and be able to. Because if you try to memorize those formulas, I tell you, I don't know all of them off the top of my head, but and understanding where they're coming from, and then along with having a calculator where you can plug in, as long as that's allowed for your class, where you can plug in the data and then get the answers, it will be a little bit easier for you. Um, so it's not a direct answer. It always depends on what you've taken and what do you like in math. It's kind of like if I were to ask you, is organic chemistry is difficult? It depends on who's asking. If I took all kinds of chemistry classes and I aced them, and it's probably a little bit easier for me to understand it because I have a little bit of understanding about that. But even still, that's not true. So yes, I do trig. Um, so it depends. It really depends on your tolerance. But if in all those classes that you guys are taking, if you really sit down and try to learn it, and you have help, you should be able to pass them. You know, because I don't want to say sit down and try to learn it, but if you don't have somebody to help you, it might not. It may be hard. If you have help, you have like a tutor, and this may be helpful too. You have a question with stats, you bring it here. I may be able to help you and help you understand it. And but you really gotta do them. If you don't, like, that's what I remember doing a lot in stats. I had to do a lot of exercises so I can understand, the concept, because you will get a lot of exercises in there. All right, cool. So let's see. I think we're doing domain and range. Let me see if I have any questions. Uh, I know this isn't serious, but I would have to see the exact questions. Okay. Um, I would have to see the exact question, Alexander. So let's try to see if we can go over a little bit of domain and range. And usually, what this entails is, let me go over this, and then we can do the and range. So the domain. So let's think about when you have a function. There are certain values that you can put inside of the function. There are certain values that you cannot put in it. And what I mean by that is in R, in a set of real numbers, there are certain values, if you're trying to find a solution for them, you can't find them. So let's say that you go on your calculator, or go on Siri, or your calculator in your phone, or wherever you have a calculator, type 1/0, that you won't have an answer for that. Type square root of -5, you will not have an answer for that, because in R, in a set of real numbers, there's no value that gives you square root of -5. There's no answer for it. And if you type, what else? What else? What else I can think of? And these are like the main, and some of other stuff, like if you have log function and all that stuff. So, but if you type those in your calculator, there's a chance that the calculator will say error, or whatever it's programmed to say. Because in R, in a set of real numbers, you will not find an answer for it. So you will not find an answer for that. Um, Thank you. Thank you. The person who say I make it easier to understand math. So you will not find an answer for that. So you will not. There's no answer for 1/0, or square root of -5 in your calculator. So now what happened is is saying that, okay, so if I have a function and then it comes down to, um, if I put a value, if I put the value, let's say I have a function of 1 over x, if I put the value of 0 here, that leads to 1 over 0. That means there won't be any output for that input of 0. Now, let's back up so you can understand what domain and the range are. So the domain of a function is all the values that I can plug in inside of the function and I have an output for it. The range, so it's all the sets of output. The domain, sets of input. The range, sets of output. Now, let's start with basic stuff. So let's say I give you a function, you really can, most of the time you guys see f of x is equal to yada, 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 but you really can define a function the way that you want to. You can say if 1 goes to 5, 6 goes to 13, and 14 goes to 11, that's a function. That is a function. So now, what's the domain of this function? And we're going to start with things that make sense for us in real life. When you say f of x is equal to, when you say something like f of x is equal to 3x squared minus 5, there's a bunch of values that I can put in there. So now I'm going to start with stuff that makes sense to me in my eyes. So let's start with simple stuff. So these are the x values on the left. These are the x values. That's the inputs. And these are the y values on the right. Blue is too similar to this. Purple. That's fine. I could use black. Okay, these are the y values on the right. So what is the domain and range of this function here that I have? What's the domain and range of it? So that's the function. That's the way it's defined. It sends 1 to 5. It sends 6 to 13. It also sends 14 to 11. Random function. So what's the domain in this case? What's the domain of the function? Let me see. What's the domain in this case? Come on, guys. YouTube, Facebook. I don't see any comments on Facebook, I'll be honest with you. All right, so what's the domain of the function, guys? Come on. Okay, can you go back to it? All right, so 1 goes to 5, 6 goes to 13, 14 goes to 11. What's the domain of the function? The domain is all the sets of input. Domain, input, range, output. Inputs is, these are the x values normally, the range, the y values. So if I have here the x values and here the y values, what's the domain of this function here that we have? Let me see. You guys probably have it by now. It would be 14. No domain. The numbers on the left. Yeah, that's right. Yeah, the numbers on the left, not 14. The numbers on the left. So 1, 6, and 14. These are the domain of the function. And does that make sense? Am I confusing you by saying that the numbers on the left are the sets of numbers that are part of the domain of the function? Is this confusing? Yes, no, maybe? Let me know, because I can go over it and explain it to you in a different way so you can understand it. You understand? Kindcade. So Shane, you can graph this, but it's not a sexy graph. It's not really like a very interesting graph. I'll show you how that would look, So 1, 2, 3, and this won't be any kind of scale. So let's say 6 is right here. Let's say 14 is all the way here. So let's say 16, 14 is all the way here. And then let's say for 5, 11, let's say this is 13. And this won't be any scale. I'm just showing you the sketch of what this would look like. So 1 goes to 5, 1, 5, that's a point. 6 goes to 13, 6 goes to 13, 6, 13, that's another point. And then 14 goes to 11, 14 goes to 11, and that's another point. That's all it looked like. That's all it would look like. These three dots. That's all it would look like. So it's nothing sexy or anything. So in this case, what we want to do to find a domain, you don't have to graph it. You don't have to graph it because you see all the numbers that are here. All you have to do is saying, okay, the numbers on the left are the domain. So the domain are all the sets of numbers on the left. So the numbers, the sets of input. So the way I normally explain this to you guys is saying, hey, if I have a oven, there are certain things that I can put in it. There's certain things that I cannot put in it. Same thing with a microwave too. So if I put, I can put aluminum foil in the oven, and I can put raw chicken and get cooked chicken. I can put dough and get, I don't know, some bread or cake or something like that. So you can put certain things, the set of stuff that you can put inside of the oven are like the input. The raw chicken, the dough, the pasta that you can put in there, the aluminum foil that you can put in there that covers the thing. All of those are part of the input. The outputs are like the cooked chicken that you get, the cake that you get after you put that inside of the oven. All the stuff, all the sets of output. Now, what happened if I just throw one of my shirt in the oven? Eventually what's going to happen, you're going to smell something at your house. So that's part of the stuff that you cannot put in it. You cannot put inside the oven. There is no, if I'm considering the fact that I don't want to cause a fire at my house or smoke, some stuff that you cannot put in the oven or like, paper. Like you can't just throw paper out in it. You can't just throw a bunch of other stuff in there. So these are the sets of output. So now let me explain this in a way that you guys probably understand too. Like let's say you play video games. So let's say there is let me see if I can find a console here. Okay, so there's a up button. Let's say there's a up button, down button. I don't play a whole lot. And then there's, you guys know this, there's an X and a Y. So these are part of the console. So let's say it looks like this. This is a part of it. So these are like the sets of inputs. You can have a combination of them. When you combine this and this, the guy jumps. So the jumping part is like the output. So pushing forward, he moves forward. This is the input. I push this thing forward and he moves this way. The moving this way is the output. If I put X, let's say I'm playing Mario and I put X, Mario jumps. The input is X. The jumping part is the output. So, and that's all it works. That's how it works. The thing that you put in there is the input. The stuff that are out is the output. Now, let's say if there was and I'm considering the fact that I don't want to mess up my game. Let's say combining these two buttons and this X cause mess up your game. It's if I'm considering the fact that I don't want to mess up my game, this is an output that you don't want to do put in your game. So that would be like having 1/0 or something like that. So in the realm of possibilities, in terms of, hey, I want all the possible combinations that will not mess up my game, that will not cause my game to set my game on fire. So that's how I would explain this to you guys. Now, things can get more, and does that make sense? Does that make sense in terms of input and output? And if I want to find the range before I go in this, what's the range in here in this function? What's the range? What's the range in here? What's the range? And I'm giving you the answer as I'm showing it. All right, Sammy. Okay. Yeah, the values on the right, the sets of output 5, 13, and 11. So that's the sets of output. Now, things are not always that easy. So let's say you walk up to a guy, he said f of x is equal to 1 divided by x minus 5. What is the domain of this function? So now, when I'm thinking, I want to say, okay, what are all the possible value that this function can take? What are the possible values that this function can take? Can it take possible positive values, negative values? Can it take the value of 0, 5, 15? Now, what I want to do is when you have a denominator, all you have to verify is verifying that this denominator is cannot be 0. And the whatever value that makes it 0 is not part of the domain. That's not what you want. That's what you don't want in the domain. So what I want to do is, because I can't possibly say, hey, this value doesn't make it 0. This one doesn't. It's part of it. This one does it. So the easiest way to do that is saying, okay, let me trying to make it 0. If I find something that makes it 0, I just if I find something that makes it 0, I just say, okay, the domain is all the numbers except for that value. So I'm doing well. All right, let's go with Nessie 14. I will not mess your name today. All right, so if I find the values that make it 0, if I find a value that makes it 0, that's the domain will be all possible values in the real numbers except for that thing that makes it 0. In terms of the microwave, it would be that paper towel that explodes the microwave. In terms of microwave, it would be that aluminum foil if you put it in a microwave that explodes. So that would be the thing that makes it, that makes it not work properly. So in this case, what I want to do is saying, okay, let me set x minus 5 as equal to 0. So what do I need to do in algebra? You add 5 to both sides. X is equal to 5. Right? Cool. Now, what is the set of domain? The domain is all x such that x is different from 5. And that's the set of domain. That's the all values of x such that x is different from 5. The reason why I say such that x is different from 5 is because I want everything except for that value of 5. Now, what happens if I try to plug 5 in there? Let's try it. If I'm trying to plug 5 in there, what happened is 1 over 5 minus 5 is equal to 1 over 0. If you have any calculator or your phone, trying to type 1 over 0 in there. And you tell me what you get. Now, so that's the reason why I'm working on domain. And you have to go on YouTube to see it. To see the screen, to see my computer screen. You're not allowed. There's no way. I mean, TikTok don't have a way to share it, or Instagram. Oh, it's been about an hour, so Instagram about to go out. Let me try to post this. I'll post it. Yeah, Instagram about to go out. You guys have about 22 seconds left on Instagram. Then it's gonna go out. I'll start another one. So yeah, if you want to see anything that I'm doing, just go on my YouTube channel, The Jax Tutor, and you'll see everything that I'm doing on YouTube. Yeah, so the domain in this case would be all the possible value except for that one that makes it 0, that makes the denominator 0. Let me give me 1 second. Let me try to take series and sequences. I'm trying to post this on Instagram because it's not and go live again. Otherwise, these poor folks on there won't see anything. All right, not yet. So yeah, thank you, Mateo Gel. Thank you. I think I messed up your name. School starts tomorrow. Yes, you can come back here anytime. Yes, it's not every night. It's Tuesday, and I'm trying to add some more days, but I'll let you guys know eventually when I add them, when I have sets days. Sometimes I just pop out of nowhere to just say, hey, I'm live. Yeah, so it's not every time. Welcome back on Instagram. You guys, I know there's an hour limit to the live sessions here. So yeah, So yeah, do you guys understand the domain? Do you understand the domain? Do you understand the domain? Yes, no? Okay. Any questions about domain? Yes. Okay. Now, let's see if we can find a range of this function. So let's say we want to find all the possible values for this for for the one that we just showed here. So what the range is possible y values. So let me uh let me try to find the possible y values for. So let's say I'm trying to find the possible y values of this here. So who can tell me what are the possible y values of um 1 over x minus 5? And I'll show you guys I'll show you guys a site uh so I'm gonna show you guys a site that you can use to find answers to some of the questions that you may have a little bit. So who can tell me what are the possible y values in here? Um, what are the possible y values for this right here? For 1 over 5. So what are the values of y that this can take? What are the values that y can take? 1 over 5. What are the values, possible values that it can take? So f of x is equal to 1 over x minus 5. And I'll write this way. And what's the range of this? What's the range of this? Yes, it's sharing now. I was trying to find a site for you guys too that can help with stuff. You know, I mean, it's kind of like I would say maybe like photo math, but you got to use it with be careful so you can understand the stuff when you're actually doing them. You know, the explanation makes a big difference because you can go in there and find answers to stuff anywhere. You know, you can just Google it and find answers to it. But the explanation is what's really, really important. Gonna help you understand it. So, what's the range of this? Without a bunch of talking, what's the range of this? What's the range? If you have a graph, yeah, you can. If you don't have any table, yes, you can. So I'll show you. So so let's say and you guys think about the the range for me. I'm trying to answer Shane's question. So let's say you have a graph like this. So um let's say I have a graph. So let's say this is 2, 5, and then -1. So let's say I have a graph that goes. So if the graph goes this way and that way, right? Say I have this graph right here. So Shane, are you seeing my screen, Shane? So let's say I have this graph right here. So she has a question about finding the domain and range if you just have the graph and you don't have the. So let's say these are the asymptotes. So this is two horizontal asymptotes. Let's say we have for this graph, and we want to find the domain and the range of this graph. So let's say to find a domain in this case, what you would do is saying, hey, what are all the possible values? All right, purified 0, no problem. You have a good night, my man. All right, so let's say we want to find the possible x values for this function, possible domain all the x values, the possible x values, and you can see in this graph all the way out to infinity to the left, it goes all the way out to the left, all the way out to the right. So that's when you have this graph right here. There's no restrictions on the x values. It goes all the way out to the left and all the way out to the right. You see it. You see it, right? Now, what are the restrictions on the up and bottom of this graph? Oh, I don't know why. I got to find a better way to set that up on my Instagram. So what are the possible x values for this graph? What are the possible y values on this graph, the graph that I have here? So the possible x values is negative infinity and infinity, because it goes all the way out to the left and all the way out to the right. Let me make sure that I kind of want to make sure that the Facebook is still on there, because someone asked a question earlier. So it goes all the way out to the left and all the way out to the right, right? Now, what are the possible y values? What's the range of this function? So this would be the domain of the function, domain. Now, what's the range of this function? So all I see is say, hey, when I go all the way out to the left, and you probably can't see my screen, I'm gonna do it this way. So when I go all the way out to the left, what is the restrictions? There's no restrictions on the left, there's no restrictions on the right. So this graph right here goes all the way out to the left and all the way out to the right. There's no restrictions at all on this. Now, what are the range? The range is up and down, up and down. The domain is left and right. The range is up and down. So now in this graph, what's the range? And I already defined the domain. Okay, Evelyn, I'm gonna show you. I'm gonna send you somewhere where you can find answers to most math questions. Now, if you have difficulty with the explanation, I can try to explain some stuff for you. So the question that you have right now, Evelyn, the range Shane infinity would be the domain. The question that you have right now, Evelyn, I'm gonna show you a site, and I think I can pull it up now. Let's see. Can you guys see this site? So if I want to see range domain, can you see my screen? Let me see if I don't know if I have the site on there. Okay, you're able to see the site. So go to Wolfram Alpha, type Google Wolfram Alpha, and this is I don't know if I should have given you this, but you would find it anyways because it would come up. If you go on this, you can type in any questions and try to find an insert to it. Now, if you need the explanation, I can try to explain it to you and see, hey, this is why this is the domain, this is why this is the range. But if you need a quick insert quick, like you said, and you could do this way. All right. Any other questions? The range infinity 5 and 5 infinity, since 5 makes the denominator 0. Okay. Now the range is no. So where are you getting this from? Shoot. I see where you're getting this from, but that would be like the domain. That would be what the domain is, from negative infinity to 5 and 5 to infinity. That would be the domain. The range would actually be different. The only value that this function cannot take, 1 over 5, the only 1 over x minus 5, the only value that this cannot take is 0. If you think of it, because this doesn't have an x here that you would place by 0 to get 0, only value that this cannot take is 0. And also too, I believe this function has, like, if you try to graph it, you're gonna get a asymptote at 0. So what you say is the only value that you cannot put in here is, the only output that you cannot get is 0. So now, how do you know the range? There's not really like a formula. Usually you see the function graph and then you'll be able to see it. In this case, it's easy because I know I can try to put values. So I can put any negative number I put here. Let's say I put -6. I'm going to get a function that's negative. I can get a positive 1 if I put any numbers greater than 5. If I put 13 here, I'm going to get a positive number. The only value that this function cannot take is 0, because it cannot be 0 at all. It can be 1, 2, 3, 4, 5, 15, 5.2, but it cannot be 0, depending on what value you put in it. It just cannot be 0. So that's the only missing value in the range. Does that make sense? I feel like I'm answering 15 questions at the same time. Okay. Yeah. Sammy, does that make sense, Sammy? So Evelyn, the site that I just gave you will give you the correct answer, but not just Google, but it's a credible site. That way you can go and find the correct answer to that question. If I'm looking at the numerator, yes, because that's the only way you get 0. Sammy, I think Sammy, you don't want to ask the question. Yes, that's the only way you get 0. You're welcome, Evelyn. That's the only way you get 0. So I'm gonna go back in the range, Shane. That's the only way you're gonna get 0, because otherwise you will not get 0 for this function, because it cannot get 0. So 1 over x minus 5. This one will never be 0. It'll never be 0. There's no value that you can put here to get a 0, and that's why it's not part of the range. And let's go. Hey, what's up, Barbara? Let's go back to. If you want to see the screen, go to YouTube. Let's go back to the question that we had earlier. Let's see. Let's go back to. Oh no, that's not this page. Let's go back to the previous page. Okay, so now how do you find the range? And I already told you that the domain of this function is the values all the way to the left and the values all the way to the right, the domain. So it can take everything from negative infinity to infinity. That's the domain. Now range, so domain, we're going left and right. Range, we're going to go up and down. Now there is restrictions. Here, I'm bounded by -1, because you see it here. And up here, I'm bounded by 5. There's restrictions on the up and down. On the up and down, there's restrictions. On the left and right, there was no restrictions. On the up and down, there's restrictions bounded by 5, the horizontal asymptote here, and also bounded on the lower half by -1. So now what we're saying is the range of this function is what? Shane, I want you to answer for me, if you can. Shane. Okay, I understand. No problem, Sammy. So if you can understand, if you can, what I'm saying is with this function that I graph, and let me make this a little bit cleaner. Let me redraw it. So what I had is 2 asymptotes, one at -1, one at 5, and then the function, and then let's say this is the x-axis, this is the y-axis. The function was going this way. It went this way, and then that way. Now, what happened is the function can only take values between -1 and 5. Y values. Can the function be 15? No. Can the y value be 15? No. Because it's only taking y values between -1 and 5. Can it be -4? No. So what is the range? What are the possible y values? That's what the range means. What are the possible y values? And that if there's more questions about this, I'm willing to do a bunch of examples next time. I'm gonna set it up and do a bunch of examples, because it sounds like you helped me pass geometry freshman year. I want to thank you. No problem. No problem. I'm happy to help. So yes, -1 and 5. That's why, Shane. That's why you got it. So now, if you go back to your own problem, if you see any restrictions like that to the left or to the right, or up and down, we'll be able to see, hey, okay, these are the range and the domain. So in here, there was no restrictions to the left or to the right. I can go all the way out. Let me be silly for a second. I can go all the way out this way. I can keep going this way, keep going, and I'm doing this on purpose. I can go all the way out this way, and I also can go all the way out to the right, all the way out to the right. And that may seem silly, but you get the point. So I can go all the way out to the left, which is negative infinity, all the way out right, which is positive infinity. The only thing that I cannot do is pass. I can't pass -1. I can't pass -5. So the restrictions on the left and right, which are the domain, are none. Negative infinity, positive infinity. The restrictions on up and down, which are the range, are -1, 5. Shane, you got the answer correct. The range is -1, 5. Cool. Any other questions? I know somebody asked about system of equation. Is this person still here? Because we can do them. System of equation person? Question? Any questions, guys? No, you cannot use bracket. The reason why is these are asymptotes. So the function never touches the asymptote. It never. That's why it looks like it's a horizontal line when you get to here. It never touches it. So you cannot use a bracket. It needs to be parentheses. So the function never takes the value of -1. It never takes the value of 1 of 5. So you cannot use a bracket. When you use bracket is when it can take that value. In this case, it never takes it, because when you have an asymptote, the function does never become that value. So if you graph in 1 over x and you have an asymptote at 0, the function will never take the value of 0. Does that make sense? Yeah, so it won't even touch this at all. We can go all the way out to infinity, left and right. It will not touch this at all. Yes. So yes, Shane. When it touches, you can use bracket. When it takes that value, you can use bracket. But in functions, when you see them, they graph it this way, it will. That means, especially they're gonna put a line here when they talk about asymptote. That means it will not take that value at all. Even if you go all the way out to the left, all the way out to the right, it will not take that value at all. That's that's for fact. It will not take that value at all. So you cannot use the bracket. You have to do parentheses. Yeah, you use the bracket when it can take that value. In this case, it will never take the value of -1 or 5. All right, cool. Guys, any other questions? I'm trying to do the I want to do the system of equation for the person who asked, but I don't see that person here. Any other questions about system of equation, about anything? Shane, do you understand now? Thanks, somebody else. Let me see if I can find some questions. Thanks. No problem. Do you understand? Uh-oh. Wait a minute. Okay, I don't know. Somehow they banned my live stream on TikTok. I have no idea why. I'm sure they're gonna. I don't know why. It just banned my live streaming on TikTok, which makes no sense at all. Last time they say I violated community stuff, which has no sense, but makes no sense. I have no idea why. Why do you been alive? All right. So I have no idea why. Yeah, I got banned on TikTok, yo. So if you come here, that's the only way you'll be able to see my stuff. Says tomorrow for a refresher, and I had trouble at first, but now I remember. Okay, good. I'm glad I was able to help, and I think this is it for tonight, guys. And I'll come back again next Tuesday to help you guys. I just so if you don't see me next Tuesday, I'll be live at 9:15. You just gotta go on YouTube directly to find it because apparently TikTok just banned my live stream for no reason. I have no idea why, uh, but it happens. Hey, I'll catch you guys another time, and thank you for coming by and hanging out with me. And I'll see you later. And I hope I was able to answer your questions. Yeah, thank you. You're welcome, Sammy, and everyone else. Thank you. And I'll see you guys later.